Hello students, I hope that you are good, well and fine. In today's session, what we will be studying about is matrices. Okay, today we will be studying about matrices. This is what class 12, chapter 3. Okay, chapter 3 matrices. In today's session, what we will be seeing about the introduction. We will be seeing about what do we mean by this term matrix, and we will see some types of matrices and then equality of matrices. Okay, so let's right jump to our first thing, which is the introduction part. So why we need, why is a need of matrices? Okay, so let's see. So the concept of matrices is the result of an attempt of obtain compact and simple methods of solving linear equations. Okay, linear equations. So the solely or the mainly objective of matrices is to solve what? System of linear equations. Okay, linear equations. Through matrices, you will know that how we are going to solve bunch of equations, bunch of linear equations. Okay, bunch of linear equations with very ease. Okay, in previous classes you have learned like this. If you are given this equation, then you can directly solve this. Okay, if you are given this equation, you can also solve this. Okay, using the elimination. What if you are given with say 10 equation with 10 variables? Then how you are going to do that? In that way you are supposed to use what? Matrices will help you a lot. Okay, the only purpose matrices serve is not only the main purpose matrices serve is to solve big system of linear equation. Okay, clear? Okay, this means what? This means that matrices contain important information. And what now question comes that what is matrix, how it is represented, how it is actually look. So matrices is an ordered rectangular array. So array means collection of elements. Okay, array means collection of elements. So it is a rectangular array. Rectangular array means like your collection, you can put your collection in something like this bag, yes, but matrices mainly mean collection of elements or the information or information in a what? Rectangular form like this. This is what your rectangular form looks like. Okay, now clear? And and your elements will be in here. Your elements will be in here. Okay, so far so good. So array of numbers, or even they can be functions. You can put your functions like cos x, sin x, fx, gx, anything. Okay, clear? Now the numbers or functions are called the elements, so we call them as elements, as we already said. Elements or entries of the matrix. So this means cos x is one of the entry. Okay, clear? So matrices, so far what do we mean by matrix? Matrix is just collection of information, collection of numbers, collection of functions, or specific term is array of numbers, and that array must be in what shape? The rectangular form, the rectangular shape. Okay, now this must be ordered. So this is an ordered rectangular form, so there must be some order to it. You can't uh, suppose in one matrix you put f cos x and gx, and in other way of representing this you put gx here and cos x here. Okay, you cannot what? Make variations. If you fix things, please fix it. Okay, you cannot what can you say? You cannot be allowed to change your entries at each step or every next step. Okay, clear? If the context is given, so by the context it must be fixed. Okay, clear? Okay, let us move to next. Now example. So for example, this, as you can see, this is what my rectangular form, and my entries are -2, 5, 0, √5, 3, 6. So in some context you can say this is representing something, this is representing something, these all are representing something in their specific position. Okay, so mainly your matrix is divided into things. What things? The rows. So row 1, row 2, row 3. We say this is called rows, and this we called as columns. Clear? Rows and columns. Okay, our matrix. Okay, so our matrix has two things, column and rows and columns. Okay, as you can see, horizontal line of elements said to constitute rows and vertical line of elements are said to constitute columns. Clear? Okay, so this means this matrix, now this matrix has 3 rows and how many columns? 2 columns. As you can see, 2 vertical lines you can easily draw like this, 2 columns. Okay, clear? Okay, so far so good. Now B has 3 rows and 3 columns. 3 rows and 3 columns. Clear? Rows and column concept is clear. Okay, now order. So as we saw the rows and columns, now we define what do we mean by order of the matrix and what information does this gives. So order means having m rows and n columns is called a matrix of order m cross n. This means if you are saying that this matrix, suppose A matrix is of order 2 cross 3, is of order A is of 2 cross 3 order. Okay, so this means that this number must be saying about the rows. So how many rows we will be having? We will be having 2 rows. And how many columns we will be having? We will be having 3 columns. Okay, so this means you can write your rough matrix according to this, or you can construct your matrix according to this given information like this. So you must have 2 rows. So 2 rows, entries are not given to you. You can put anything. So A, B and 3 columns. So this means C and 1, 2, 3 like this. So as you can see, 2 rows but 3 columns. Okay, clear? So this is what do we mean by row and column and order of a matrix. So this order of a matrix gives me what information? How many elements I am having. So as you can see, I will be having how many entries or elements? 6. And this specific form, this 2 cross 3 form gives me specific information about how many rows I am having and how many columns I am having. Okay, clear? Okay, so I hope that this is clear to you. Let us move to next. So if a matrix has 8 elements, what are the possible orders it can have? So this means I have to construct a matrix. With 8 entries in it. 8 entries, suppose 1, 2. How can I make? So this means I have to define its order. Quite simple. I can make my matrix like all just consisting only one row. Consisting only how many row? One row. So this means 1, 2, 3, 4. So this means all 8 entries in a single row. So this will be of what order? As you can see, how many rows you are having? 1. How many columns you are having? 8. This is indeed we are getting 8 elements. Okay, total number of elements will be row multiplied with column. So you will be having 8 entries. Okay, now what another representation can you make? Quite simple. You can think of this 1 8. Now you can also say that 8 cross 1. Yes, now your all 1 to 8 entries will be in a single column having 8 rows. So this means 1 2 3 till 8. So this means how many rows? 8 rows. How many columns? Only one column. So this means now total entries will be 8. Simple. So can you make another? Yes. So you can think of, say, so you came up with 1 multiply with 8, 8 multiply 1. Now 2 multiply 4, 4 multiply 2. You can make 2 columns, 2 rows, 4 columns, and 4 rows, 2 columns. In this way you can also make. Yes, can you think another way? No, you cannot think. Why? Because you want this 8 in such a way that you want that this a can be rewritten as multiplication of two numbers, multiplication of two natural numbers. We want two natural numbers to be here. Yes, yes, and their product must be 8. So you all know that first of all, if you evaluate or if you find the all factors of it, you will find 1 2 4 and 8, only these factors. Now this and this only gets paired, and this only gets paired. No other elements you can find. Okay, you cannot use your rational number here. As you saw, the number we are taking, rows means number means the counting numbers we are taking. Okay, counting numbers we are taking by default. So they cannot be rational or anything number, they must be counting numbers. Okay, so only 4 possible way you will have in which through which you can represent your a matrix with having 8 elements in it. The two representation I have already provided you. Please do the for these also. Let me do it for you. This will be 2 cross 4 will be what? As you can see. So 2 rows means 1 and 2 rows, and 4 columns 1 2 3 4. Okay, now at the point of intersection you will say that 1 2, or let me use different color. So 1 2 3 4 5 6 7 8. As you can see, you are having 2 rows 3 columns. Ordered will always be mentioned in this right bottom position of a matrix. Right bottom position of a matrix. Okay, now as you can see, we are having 2 rows and 4 columns, 2 rows and 4 columns, in total 8 entries. Okay, I hope that it is clear. Now 4 cross 2 will be like 1 2 3 4 5 6 7 8. 1 2 3 4 columns, 4 rows 2 columns, means 4 rows 2 columns, 8 entries. Clear? Okay, let us move to next. Now, as we already saw, we will have only 4 such possibilities. Okay, now in this example we have to construct 3 cross 2 matrix. This means having 3 rows and 2 columns, 3 rows and 2 columns. Okay, whose elements are given by this? What do we mean by A I J? This means this A means the entry of what? Entry of a matrix. And what matrix? This matrix. And IJ means, then we know the matrix, we know the entries, we know about rows. We will have 3 rows and 2 columns. Okay, in total 6 entries, 1 2 3 4 5 6. And how we are supposed to know that what entry it will be? This or this? So that information will be inherited in this thing, IJ. This means the row and this means the column. Okay, column position. So this is ith row and jth column. So in general, this will be what? A11. Yes, first row, first column. This means first row, second column. This means second row, first column. This means second row, second column. Third row, first column, and third row, second column. This is what do we mean by ij. Okay, so ith row, A will be the entry of ith row and jth column position. Okay, I hope that it is clear now. So in A11 means I and J are 1 1. So A11 entry will be, as you can see, A11 must be mod of 1 minus 3. Yes, and this will be what? Minus 2, and minus 2, you will get your answer as 1. Okay, so 1. Okay, now 1 2. This will be what? 1 2 1 half. 1 minus J will be 2. J is 2. So this means 6. So this will be 5 by 2. Okay. Now what about 2 1? 2 1. 2 1 means 2 minus 3. This means minus 1. This means half. Okay. What about 2 2? This means 2 minus 6. This means 4. Yes, 4 by 2. This means just 2. What about 3 1? Yes, 3 1. 3 1 means 1. Sorry, 3 minus 3, you will have 0. Now 3 2. 3 2 means 3 minus 6, you will have 3. So 3 by 6. Okay, so 3 by 6. 3 by 6 means half. Okay, for 3 2, let me evaluate once again. So 3 2, this means minus 3. Yes, this means minus 3. Okay, this means minus 3 means 3 by 2, not 1 by 2, it will be 3 by 2. Okay, I hope that it is quite clear what is happening now. So we are already given the how many rows and how many columns we will be having, and the entries, how my entries will be looking like. This information is given by this thing. This in general, Aij means entry of ith row and jth column position. Okay, I hope that it is clear to you. So your final matrix 3 cross 2 will look like this, which satisfying this given information. Okay, let us move next. Now, as we already saw our, okay, so as you saw the solution, so let us move next. Column matrix. Now, types of matrix. What do we mean by types of matrix? We saw what do we mean by matrix. We saw order of a matrix. We saw how to construct a matrix if you are having some information. Okay, on the basis of that information, how you construct it. Now we will see types of matrices. What are the different types? So different types. A column matrix. So what do we mean by column matrix? So column matrix means you are having just a single column, only one column. In a matrix, if you are having only one column, this means that matrix is a column matrix, as you can see. Yes, in this you are having only one vertical line, means one column, means column matrix. I hope the definition is clear. The example is already given to you. In general, if you think of order, what will be its order? As you can see, you are having 4 rows. Yes, so this means 4 multiply 1. Yes, in column matrix you will always be having 1 here because of the one column. So in general, if you are having m rows, then in column matrix you will multiply m multiply 1. So this means the m rows and 1 column. Okay, in general, we will be representing our matrix by what? Aij thing. Okay, m cross 1. Okay, this Aij means what? A will be like this, A11, A12 till what? So here in this example, A11, so we are having only one common, so A11, A21, A31 till AM1. So your matrix will be like this in general. Okay, I hope that it is clear. Let us move next. Now row matrix, as we saw, the column matrix definition is by just its name. Same will be happening here. So row matrix means matrix having only one row. Matrix having only one row. If you are talking about its order, the order will always be start with 1 and multiply with how many columns you are having. Suppose you are having m columns, then it will be multiply with m. So if you see like this, so how many vertical lines you are having? 4. Or how many columns you are having? 4, and only one row. So this means 1 cross 4 will be your order. Okay, I hope that it is clear. So having only one row will be what? Your row matrix. Will be what? Your row matrix. Okay, now square matrix. What do we mean by square matrix? Square matrix is just nothing but, so first of all, let me give you what do we mean by this thing, Aij and m cross n. This means we are having m rows. This means we are having n columns. Okay, so this thing is representing that my matrix in rectangular form. How? So this thing is what? 1 1. Yes, first row, first column. How many rows I am having? M rows. So this means second row, first column, third row, first column, till I will get my mth row and first column. Yes, clear? So why? Because this is my first column and this is my mth row. Okay, now this column will be what? Second. So first row, second column, second row, second column, till mth row, second column. In this way, you can get up to where? First row, nth column. Your final or the last column will be nth column as given in this information. The order will be m cross n, having m rows and n columns. So this will be what? Second row, nth column, third row, nth column, till you will have what? The last entry will be what? Mth row and nth column. So this little thing, this thing over here, we are representing by this. Okay, so we are not going to write every time this big rectangular form. We only condensed our form into this simplest. Okay, so whenever you see such type of thing, please do make respective matrix according to that. Okay, I hope that it is clear. Okay, now, so for example, this means what? Having m rows and m columns means your A matrix will be having m rows. So this means starting from 1, m rows. Okay, now m columns. So this, your final entry will be am. Okay, now order will be what? M cross m, as you can see. So whenever you have what? Whenever you have same number of rows and same number of columns, then that type of matrix will be square matrix. Okay, that type of matrix will be square matrix. I hope that it is clear. For example, this is what? Having 3 rows and 3 columns. So 3 equals to 3. This means this is what? My square matrix. Okay, square matrix. I hope that it is clear to you. Okay, now let us move to next. I hope that it is clear. Now diagonal matrix. What do we mean by diagonal matrix? So diagonal matrix is, first of all, it must be a square matrix. Okay, so a square matrix is said to be a diagonal matrix if all its non-diagonal elements are 0. Or okay, all its non-diagonal elements are 0. Okay, we will be calling it as diagonal matrix. For example, so what? First of all, what do we mean by diagonal matrix? Diagonal matrix are elements you having A11, A22, these positions, A33, A okay, so these entries, or if you, because of this is what your square matrix means, same number of columns, same number of row. So elements having elements in this path, elements or entries in this diagonal, we will be calling them as diagonal entries or diagonal elements. Okay, or in this way, A11, A22, anything like that, where A at this position, they will be at the same what? ith row and jth column. This means I and j must be same. Okay, so this will be calling, we will be calling them as diagonal elements. And apart these diagonal elements, we are not saying about these diagonal elements, we are saying about elements removing these will always be 0. Okay, so for example this, so these are what? My diagonal elements. And if you try to see your elements, your non-diagonal elements like this and like this is 0, are 0. This means by definition it will be what? A diagonal matrix. Okay, I hope that it is clear. Another example you can take, say 1 2 3, so 3 cross 3 matrix. So first of all, your matrix must be square. Now all entries must be what? 0. Okay, I hope that it is clear. By this definition, you can put your diagonal entry equals to 0. Indeed, because we only talked about what? Your non-diagonal elements are 0. Okay, your non-diagonal elements are 0. There is no restriction we can put or we cannot put our diagonal elements equal to 0 or not. Okay, the restriction is just non-diagonal element must be 0. That's it. Okay, so this is also what? Diagonal matrix. Okay, now let us move next. Scalar matrix. What do we mean by scalar matrix? Scalar matrix, first of all, the scalar matrix are, first of all, scalar matrix must be a diagonal matrix. So a diagonal matrix is said to be a scalar matrix if its diagonal elements are equal. If its diagonal elements are what? Equal. Okay, clear? Okay, so in general, this means you must, first of all, you must have a square matrix. Then if it is a square, then it must be a what? A diagonal matrix. Then if it is diagonal matrix, then all elements at diagonal entries means a11 is equals to a22 is equals to a33 and so on. Yes, a and n. Okay, if they all are equal to each other, then you will call it as scalar matrix. Okay, I hope that it is clear. So to be a scalar matrix, first of all, it must satisfy two things. It must be what? Square matrix and then diagonal matrix. Okay, diagonal matrix. I hope that it is clear. Okay, this will be some constant k. Okay, let us move next. For example, as you can see, this is my diagonal matrix. Yes, of order 1. This is what? My scalar matrix. Yes, as you can see, this is square matrix, 2 cross 2. The number of rows and number of columns is same, and non-diagonal entries are 0. So this means square matrix, check. Diagonal matrix, check. Now, are the diagonal entries equal to each other? Yes, -1 is equals to -1. So scalar matrix. Scalar matrix. Okay. Now identity matrix. Identity matrix. What do we mean by identity matrix? So first of all, a square matrix in which elements in the diagonal are all 1. So this means diagonal entries must be 1. So identity matrix means your square matrix in which diagonal elements all are 1 and rest are all 0. Okay, for example this. So diagonal elements are 1 and rest elements are 0. So diagonal elements are 1 and other elements are 0. We will be calling that matrix as identity matrix. And please do give a special or emphasize this point that matrix must be square. Okay, you cannot say that this is what, or you can say that this. Okay, 0 1 1. You cannot say that this matrix is identity. Okay, why? Because this does not satisfy the first thing, which is square matrix. This is not a square matrix, so not identity. Okay, I hope that it is clear. So this is of order 1, this is of order 2. As you can see, 2 cross 2. This is of order 3, means 3 cross 3. Okay, I hope that it is clear. Okay, so in general, we denote our identity matrix by I3. So I3 means with 3 columns and 3 rows. I4 means with having 4 columns and 4 rows. Okay, I in general, IN means having n cross n order. Okay, I hope that it is clear to you. Let us move to the next type, which is zero matrix. So zero matrix means that all the entries are equal to 0. As you can see, 0 0 0 0. This means zero matrix. All are zero matrices, and we denote that these zero matrices by this big O. Okay, I hope that it is clear to you. So what do we mean by zero matrix? Okay, let us move next. Now, equality of matrices. You must know about the equality of matrices. So when do we say that two matrices are equal to each other? So two matrices are equal to each other when they have the same entries, okay, at the same position. What do we mean by that? Suppose we have matrix like A12, A21, A22, A21 and A11. This is my A11 position, this is my A12, A like this. Okay, now another matrix is B11, B12, B21, B22 like this. So first of all, they must be of same order. They must be of same order. So we say that two matrices are equal if the first thing is that they must be of same order. The number of rows must be same in both of the matrix. Number of columns must be same in the both of the matrix. As you can see, 2 cross 2, 2 cross 2. Okay. Now what? Now this position, the first row, first column position must be same as the first row, first column position in the other matrix. This position must be same as this. This position or this entry must be same as this, and this entry must be same as this. Okay, then you can say that your given matrix is equal to each other. Okay, this is what written in the second point. Each element of A is equal to the corresponding element of B. We use this word corresponding element. This means if you are picking up the third row and third column entry from this matrix, then the third row and third column entry from this B matrix must be same. As you can see, the ith row and jth column position entry will be same as the ith row and jth position entry from B matrix. Okay, I hope that it is clear. For example, here. Okay, now let us see an example. As we are given this example, as you can see, this and this, so they are equal. Now see this, they are not equal. So 3 is not equals to 2. So this means not equal. As you can see, are not equal. Okay, so symbolically, if two matrices are equal, we represent it by A is equals to B. Okay, I hope that it is clear to you. Now, for example, so if this matrix is equal to this matrix, then we have to find the value of A, B, C, X, Y, Z. So how we are going to find? Quite simple. So this position must be same as this entry must be same as this. Yes, so this means X plus 3 must be 0. This means X is equals to minus 3. Okay, this entry must be same as this. So from this, what you can write is this, and this means Z must be 2. This will be same as this. Okay, so solve this. So this will be 2y minus 7 is equals to 3y minus 2. So this 2y will be at this position, and this will be minus 5. So y is equals to minus 5. So y is equals to minus 5. Okay, so far so good. Now what? Now so easy to find. Now A minus 1 will be same as this. So A minus 1 will be same as minus 3. So this means minus 2. So A will be minus 2. Okay, A will be minus 2. Okay, this position, this entry will be same as this position entry. So B minus 3 will be same as 2B plus 4. Yes, 2B plus 4. So this means what? That minus 7 will be same as B. So B is equals to minus 7. Okay, Now, so now this entry must be same as this entry. This position entry must be same as this position entry. Means 2c plus 2 is equals to 0. So this means c must be minus 1. So c must be minus 1. I hope that it is clear. So value of x, y, z is minus 3 minus 5 2. As you can see, value of x, y, z is equals to minus 3 minus 5 2. As you can see, minus 3 minus 5 2. Okay, and ABC values are minus 2 minus 7 minus 1. Minus 2 minus 7 minus 1. As you can see, minus 2 minus 7 minus 1. Okay, I hope that you understood every concept in today's session. Okay, the types of matrices, what do we mean by matrices, the main objective of matrices, the forms of matrices, the equality of matrices. So that's it for this session. We will be back with more interesting insights of this topic, matrices. Okay, so thank you all.